2004 Canadian Open Mathematics Challenge, Part A. If x plus 2y is 84, and that is also equal to 2x plus y, what is the value of x plus y? We have been given two equations, so let's write them out, one on top of the other, like that. And then we'll just add them. So this becomes 3x plus 3y, and this is 168. Factor out the 3, and you've got x plus y, 168. Divide through by 3, and you get x plus y is 168 over 3. And that is 56. The value of x plus y. Let S be the set of all 3-digit positive integers whose digits are 3, 5, and 7, with no digit repeated in the same integer. Calculate the remainder when the sum of all the integers in S is divided by 9. Let's first list all these numbers. So basically we have to make 3-digit numbers with a 3, a 5, and a 7. Okay, 357 is one of them, 375. And then the lead off we can use as 5, 537, 573, and then 735 and 753. So this would be my S. This is the set. Now what they're saying is they want you to add them all up. So what I do, if I add all these numbers, the sum is 3330. And then they want you to divide by 9. Okay. When I divide by 9, it's 370. Exactly. And the remainder, therefore, is 0. And that's it. In the diagram, point E has coordinates 0, 2. And B lies on the positive x-axis, so that BE is root 7. Also, point C lies on the positive x-axis, so that BC is equal to OB. If point D lies in the first quadrant such that angle CBD is 30 degrees and angle BCD is 90 degrees, what is the length of ED? Let's start labeling this now based on what they told me in the question. So E is 0, 2. So that means this length from there to there is 2. Let's just write that in there. And then what else do they give us? Give us a bunch of angles, right? This is, so I got to draw this out. Okay, let's draw this out first. Before I can label the angles, I actually have to draw the triangle. So I got to connect those. Okay. Then they tell me that CBD is 30. So CBD, this angle in here is 30. And then BCD, so this is a right angle, 90 degrees. And then obviously that's 60. So we got a 30, 60, 90 triangle for the 1000th time on a math contest. Okay, what else can I label? This, they've already labeled for us that those two are equal. That's what those symbols mean. And BE is root 7. Okay, so this hypotenuse, because this is a right angle, right? Because obviously that's the x and y axis meeting. Okay, I think that's good enough for now. What else? Anything else that I can label? I don't think so. Okay, so here we go. The first thing, of course, is I've got to find out some, to find the length of ED, right, which is from here to here. I've got to find the coordinates of E and D. Well, the coordinates of E I already have. The coordinates of D will definitely be something I will need. Okay, so that's what I'm going to concentrate on. And to get that, I just have to look at this 30, 60, 90 triangle. All right, so from O to B, this distance, I will call X. And then BC is the same, so that's also X. Okay, X I can figure out pretty easily with this triangle. It's just a right triangle, so we just use Pythagoras. 2 squared plus X squared is equal to root 7 squared. So that means 4 plus X squared is 7, and therefore X squared is 3. X is root 3. Okay, great. So X is equal to root 3. So then now we can use that 30, 60, 90 triangle to figure out the sides, the other two sides, I should say. We really only need to figure out, I think, this side. Because if this is root 3, and this is also root 3, that means the x-coordinate of D is 2 root 3, right? Because the x-coordinate of C is 2 root 3. 2 root 3 is 0, because it's on the x-axis. And then since D is 90 degrees to C, when you draw that line, the x-coordinate of D will also be 2 root 3. And then now we just have to figure out the y-coordinate of D. And then we can do that with 30, 60, 90 triangle. If you have any 30, 60, 90 triangle, this is 30 degrees, this is 60 degrees. The ratio of the sides are always 1 to root 3. So they made it easy for us, right? Because this is root 3, so that means this must be 1. So that's nice of them to do that. So that means this is 1. Okay, great. Now we can just use the distance formula to calculate the distance from E to D. That distance. We've got 2 root 3 minus 0 squared plus 1 minus 2 squared, all under the square root sign. So 2 root 3 squared is what, 4 times 3, which is 12. And then 1 minus 2 is negative 1. When you square it, it's 1. So root 13 is the length of ED. A function f at x has the following properties. F at 1 is 1, f at 2x is 4, f at x plus 6, and f at x plus 2 is f at x plus 12x plus 12. Calculate f at 6. Well, let's start off with x equals 1. When x equals 1, we have, using this equation, f at 2 times 1 is equal to 4 at f at 1 plus 6. So that means this is f at 2 is 4 times f at 1, which is 1, that's been given, plus 6. So that means f at 2 is equal to 10. Okay, let's keep going. Let's calculate x equals 2. What happens? And I'm going to stick to the same formula, this guy right here. I think it should be helpful. So that means now we have f at 2 times 2 is equal to 4 times f at 2 plus 6. That means this is f at 4, and this is 4 times f at 2. Well, f at 2 we just figured out was 10. So 4 times 10 plus 6. And this is 46. F at 4. Okay. Now, let's see, where do we want to go? I think we can jump to this guy now and use f at x plus 2 with x being 4. Yeah. So that would mean f at 4 plus 2 is equal to f at 4 plus 12 times 4 plus 12. This is f at 6, which is what we want to figure out. And this is going to be f at 4, which is 46 from up here, plus 12 times 4 is 48, plus 12. And that is 60 plus 46, 106. So that's a cute little question. I like this one. It's nice because it's not that difficult, but it's challenging enough to kind of be interesting. The Rice Tent Company sells tents in 2 different sizes, large and small. Last year, the company sold 200 tents, of which 1/4 were large. The sale of the large tents produced 1/3 of the company's income. What was the ratio of the price of the large tent to the price of the small tent? I will call L the large tent and S the small tent. There's 200 tents sold in total. So that means L plus S is 200. 1/4 were large. So 1/4 of 200 is 50, right? So that's 50. And then therefore S is 150. And then they're talking about prices. So price I will just call A and B. I don't know what the prices are yet. And what do they want? The ratio of the price of the large tent to the price of the small tent. So they really want you to find A over B, according to what I have called them. Okay, so this is my task. Well, the total amount of money, income, that they made from the large tents would be the number of large tents multiplied by the price. And they're saying that is equivalent to 1/3 of the company's income. So we'll call income I, and I over 3 represents 1/3. Okay, so therefore I is equal to 158. Now, if the sale of the large tents produced 1/3 of the company's income, the sale of the small tents would produce the other 2/3 of the company's income. So 2/3 of I is the company's sales for the small tents, which would be, according to this, 150B. So multiplying through, what is that? 450 divided by 2. 450 divided by 2, so 225B, I think. Yeah, 225B. Well, now we can set these equal to each other, these two guys. So 150A is equal to 225B, and therefore A over B is 225 over 150. And that, divide top and bottom by 75, we get 3 over 2. So there we go. And then sometimes they want you to write it in this format, that A, B is equal to 3.2. It's the same thing, but whatever. You can write both. In the diagram, a square of side length 2 has semicircles drawn on each side. An elastic band is stretched tightly around the figure. What is the length of the elastic band in this position? Well, let's blow up this elastic band. Now, you might say, well, I don't know. That doesn't seem like a shape that I can calculate the area for. Well, here's the trick to the question, right? It's not really a trick, but you notice that this point is the center of that diameter. Draw a line that represents the radius to the tangent point, because that elastic band will touch the semicircle at a tangent point, and tangent points are right angles. So that's basically the strategy, and it will all sort of come into play once I get all these radii drawn in. So that is the key to these questions, these types of questions, I should say. So there we go. And a couple more here and here. Right angle. And then, of course, here and here. Okay. So now what we have to do is sort of just label this thing. The distance from here to here, I will call x. And then similarly, all those others are going to be x also, because the symmetry of the diagram, all of those is x. And then this distance, that I guess that arc, which is basically a part of a circumference of a circle, I will call a. And therefore, all of those arcs are a, since the diagram is symmetrical. So the elastic band, whatever you want to call it, EB, elastic band, is really 4x plus 4a in terms of its length. Okay, that's all I need to do is figure out the length of A, the length of B. Okay, so where do I go from here? Okay, well, it would be very helpful if I can figure out this angle, because that would give me what percentage of the total circumference is that A. Well, one thing that will help me is that if I can sort of extend this line, right, like that, that helps me tremendously, because this segment here is the same as x, and therefore this is a right angle. So that means theta is 90 degrees. And because it's 90 degrees, that A is representing 90 over 360, which is a quarter of a circle. So A is basically the circumference over 4. So let's put that in there. X I don't know yet, but A is the circumference over 4. Well, the circumference of the circle is always pi times diameter, right? Pi times diameter. Well, what's the diameter of that circle? Well, here's the diameter, right? All the way from there to there. And they told me that it's 2. That they've told you that in the question. So that means this is 2 pi over 4, which is pi over 2. Pi over 2 is the value for A. So I put that in there. Oh, well, A is the same as C over 4, so I was wondering where did the A go? Okay, well, C over 4 is pi over 2, so put that in there, pi over 2. Okay. All right, so far so good. Now I just have to figure out X, and then I'll be in business. X, how do I figure that out? Well, this is a right angle, and then from here to here, that is 1, because it's just half of the side of the square. And similarly, from there to there is also 1. So X I can get with a Pythagorean relationship of that triangle. So 1 squared plus 1 squared is x squared, and therefore x squared is 2, x is root 2. So put that there. And then this becomes 4 root 2 plus 2 pi. 4 root 2 plus 2 pi, and that is the length of the elastic band. Let A and B be real numbers with A greater than 1, B greater than 0. If A times B is equal to A to the power of B and A over B is equal to A to the power of 3B, determine the value of A. Well, this really is tempting here to use logarithms, but I'm going to try not to because I don't think we need to. Just have to sort of concentrate on the parameters that they gave us and just use exponent law. Okay, let's go for it. A over B is equal to A to the 3B, according to this. And let's manipulate this a little bit. A over B, therefore, is A to the power of B to the power of 3. That's perfectly allowable by exponent law. And A to the power of B is AB. So instead of this A to the power of B, I will substitute AB. Expanding this, we have A to the power of 3, B to the power of 3. Bring the B upstairs, and that would be A to the power of 3, B to the power of 4. Divide everything by A, and this becomes 1, is A squared B to the power of 4. And I think at this point, we take the square root. Before I take the square root, let me just write it as a square. So A to the B to the power of 2 all squared. And then when you take the square root, it will be AB squared is plus or minus 1. Okay, so hopefully that was not too bad. So we have two conditions. Either it can be equal to 1, AB squared, or it could be negative 1. Well, let's see if this is possible. First of all, if B is greater than 0, then that means B is positive. If you take the square, it will be positive. A is greater than 1, so it's positive. So both of these guys are positive. A positive times a positive can never be negative 1. So this is not going to be possible. So we have really just one scenario to work with. From this, we can conclude that A is equal to 1 over B squared. And I think that is how we're going to solve this question. A is equal to 1 over B squared. We got one variable in terms of the other, and we can then substitute it into either one of these equations and solve. Okay, so which one do you want to use? I'll just use the first one. So the first one says that AB is equal to A to the power of B. a is equal to 1 over b squared. So substitute that in, 1 over b squared, all to the power of b. This just becomes 1 over b. This becomes 1 over b to the power of 2b. Cross multiply, and we get b to the power of 2b over b is equal to 1. And then using exponent rules, b to the power of 2b minus 1, because this was b to the power of 1, is 1. And 1 is really b to the power of 0, correct? So then, that means since we have created a nice formula where the bases are the same, the exponents must be the same. So 2b minus 1 must be equal to 0. So therefore 2b is 1 and b is a half. So we finally got a numerical value for one of those two. To get the numerical value for a, we just use that formula. That a is equal to 1 over b squared. A therefore would be 1 over 1/2 squared. A is 1 over 1/4, and that means a is equal to 4. That solves this cool little question. A rectangular sheet of paper, ABCD, has AD equals 1, AB equals R, where R is between 1 and 2. The paper is folded along a line through A so that the edge AD falls onto the edge AB. Without unfolding, the paper is folded again along a line through B so that the edge CB also lies on AB. The result is a triangular piece of paper. A region of this paper is 4 sheets thick. In terms of R, what is the area of this region? Well, my recommendation, perfectly allowable even on a math contest, is take a piece of paper and try to do this folding it. So initially, of course, you will have a rectangular piece of paper, correct? And then you just fold it. When you make the first fold, you'll notice that it will have to abide by a certain number of rules. Because the thing is that at the end, it has to be a triangle. It has to look something like this. Now, of course, this is not going to be drawn to scale, but I'm just drawing it to give you an idea. That part, we know that at the very end, it's got to be a triangular piece of paper. So we've got to figure out what does it look like in the middle, that first fold, after the first fold. If you take a piece of paper and do this, you can easily figure out that it will look something like this. Well, let's see here if I can draw it. It will look something like that. There we go. And then what that really was is if you had this labeled ABCD, we just brought D up here. You see, this D came up to there. And that's basically how we did that. The rest of these are the same. That's still A, that's still C, and that's still B, and that's still C. Okay, then when we make the second fold, we bring the C up to somewhere here. So that's how we got the C up here. This is still B and this is still A. D is still here somewhere, but C ends up here. Okay, so now let's draw in a couple of lines to sort of figure out what is it that they want. Okay, well, I'm going to draw a line C all the way down and D all the way down. Now remember, this is supposed to be symmetric. And then a line across. The region that they want is right here. That is the region that is 4 sheets thick. And like I said, if you use a piece of paper, you can convince yourself of that. Okay, so now that I've labeled it, let's start labeling the distances. Okay, so here we go. We are told that the sheet AD has 1 in terms of length and AB is R. All right, so that's easy. That's just straight from the question. When this is folded like this, then we got to figure out, okay, well, what happens here? We don't really know. We don't know any of the distances, so we got to make them up and give them some variables here. Okay, I've got to give them some variables. So this distance from here to here, that's very important, right? So I'm going to call that y. The distance from here to here is also equally as important because that represents the base and height of a triangle. So I'll just call that Z. And the only way for this to work is if this ends up being an equilateral triangle. That's why I'm confident that this triangle is equilateral, and that it indeed has the same sides, well, at least two of them, and we'll call them Z. Now I've got to figure out a few other things, and that is, what about this segment here? That segment is the same as that segment. Well, if the full segment is R and this is Y, this and this are going to be R minus Y, correct? But this segment is only half of that, so it would be R minus Y over 2. Okay. And then this segment up here, which is essentially the same thing as dB, is interesting because when you folded this AD and it came up here, AD is 1, so that means AD from there to there is also 1. But this whole distance was R, so dB is R minus 1. So I hope that makes sense. Hope that isn't too confusing. Okay, well, dB, I have just concluded, is R minus 1, but I also concluded that dB is R minus Y over 2. So set them equal to each other. R minus 1 is equal to R minus Y over 2. And therefore 2R minus 2 is equal to R minus Y. And then isolating for Y, Y is equal to 2 minus R. Okay, great. Because remember, we just need to figure out the area in terms of R. It's not going to be a number. So that's good. Okay, I think we're ready for the final step, which is to figure out the area of this triangle right there. Now, because it's isosceles, we know that these two angles are the same. Now, this angle right here, this one right here, we need to know, and we can figure that out pretty quickly, because notice in this triangle this was R minus 1, correct? From here to here, it's the same as that. So when this was folded up, when C is brought up to here, what happens is that this R minus 1 is the same as this distance right here. So that is R minus 1. So, and so is this one. This distance is also R minus 1, like that. So this distance is R minus 1, right, dB, and this distance is R minus 1. So that means this little guy in here is also isosceles. And since this is 90 degrees, these are 45s. This is 45 and that's 45. And then therefore, since this is basically parallel to that, that makes me conclude that this is also 45 degrees. And so is this. So therefore, this is a right angle. So I hope that made sense. So to figure out the area of that 4-sheet thick region, it's simple. Area would be 1/2 base times height, where base is Z and the height is Z, since it's a right angle triangle. Okay, so this is Z squared over 2. And then we can figure out Z in terms of Y with Pythagoras, right? Z squared plus Z squared is equal to Y squared. So 2Z squared is Y squared. Z squared is Y squared over 2. So we got Z squared, which is Y squared over 2 over 2. This is Y squared over 4. Y we have figured out was 2 minus R. So this is 2 minus R squared over 4. 2 minus R squared over 4 is the area of the region in terms of R.